This video is for Chapter 10, Section 10.1 for the math activity Angles in Pattern Block Figures. We'll use pattern blocks and we'll determine sums of interior angles in polygons. We'll use the traditional set of pattern blocks: equilateral triangles, regular hexagons, squares, two kinds of parallelograms, and an isosceles trapezoid. In question 1, we look at the equilateral pattern block triangle. You'll probably remember that the three congruent acute interior angles in the equilateral triangle are each 60, but you can see that here by putting the 6 triangles around a circle, and then 360 divided by 6 is 60, and that helps us see and explain how we know these angles are 60 degrees. In question 1, we ask you to determine the measures of the other interior angles for all the pattern blocks. It will help to put this in a table. You'll need this later. So we know the triangle is 60 degrees. And the hexagon has one congruent acute angle throughout. Same for the square. The parallelograms and the trapezoid have both acute and obtuse angles that you'll want to list separately. And of course you'll want to draw sketches or trace pattern blocks and help explain your reasoning. Let me give you a few hints on how you might do this. Looking at the blue parallelogram, you can use the around the circle technique that we used with the green triangle to determine the interior angle of the blue parallelogram. A second technique is to compare to a known angle. You can put the green triangle on top of the blue parallelogram and see that the acute angle of the blue parallelogram is the same as the angles in the triangles. You can even apply this technique by adding two known angles to determine the obtuse angle in the blue parallelogram. And then finally, you can line up two blue parallelograms and you'll see that the acute angle and the obtuse angle add up to 180 degrees, a straight angle. And this will also help you determine the obtuse angle once you know the acute angle. There are lots of methods, as long as you're drawing pictures and thinking of kid-friendly ways to find these angles. Now, in question 2, we're just going to start exploring the sum of the interior angles of polygons. We'll start with hexagons, which, remember, that's just a polygon with 6 sides. We have pictures here of 3 different hexagons. They have 6 sides, 1, 2, 3, 4, 5, 6 each. Find the measures of each of the interior angles and compute the sum of the measures of these for each of the polygons above. So notice here, when we look at the hexagon made with the orange square and the blue parallelogram, that this angle here, although it's made from 2 pattern blocks, is combined one of the interior angles of this hexagon. So you can see all 6 angles are marked on the diagram. Once you've done this, make a conjecture. What do you think the sum of the interior angles of any hexagon should be? Then in part B, we have another hexagon, also with 6 interior angles. And notice here that this straight side is also made of 2 pattern blocks, and it's not marked as an interior angle. It's part of the side of the polygon. You can see we further noted here that point B here is not a vertex of this polygon. So find the measures, and does this match your conjecture from part A? Then in 3, we repeat these ideas, but now we're going to look at 5-sided polygons, pentagons. So form a variety of them and find the sum of the measures of the interior angles. And follow this up with a conjecture about the sum of those interior angles for any pentagon. Now in 4, we formed an octagon, an 8-sided polygon. Use arcs to mark these angles, and what is the sum of their measures, the interior angles. Once you've done this, we're going to think about polygons in general. So use your pattern blocks and form polygons with other numbers of sides, and see if you can determine a conjecture about the sum of the measures if all you know is the number of sides. You might find this analysis helpful if you make a table. So you can see here that n is the number of sides of the polygon, and I have angle sum. So for a triangle, the angle sum is 180 degrees. For a square, the interior angle sum is 360 degrees. In your work earlier, you'll have determined for n is 5, the pentagon, for n is 6, the hexagon, for n is 8, the octagon, and you might want to draw some pattern block figures and determine some of the angles for the 7-sided polygon, the heptagon. And this should enable you to hopefully determine a formula for a polygon with n sides. That's it for Math Activity 10.1. I hope you have fun thinking about angles and polygons and forming some interesting conjectures.